Alright, what we're going to look at today now is the quadratic inequality. We just watched a video on our square root inequalities. Now we're going to bring back our quadratic because they are inverse operations of each other. And what we're going to do is we're going to see how we graph it. So let's take a look. Alright, graphing your quadratic inequality is very similar to graphing our linear inequalities. It's just that now we're going to have our quadratic, so our shape is going to be our parabola. So we're going to take y less than or equal to negative x squared plus 2x plus 3, and we are going to graph it. So the first thing we're going to do is we're just going to take out the inequality sign and we're going to put in an equals. So we're really just going to graph this parabola. So a few things to note. You see that it is negative, so this is opening up or down. I hope you said down. And then we also know our 3 is our what? Did you say y-intercept? Okay. So first thing we're going to do is we are going to, so we know it's opening down. So now we're going to put in our, and find our axis of symmetry. So we're going to sub in. We know that our B is 2. And we know that our A is negative 1. So we will do minus 2 over 2 times negative 1. So 2 divided by 2 is 1. And negative divided by negative is 1. So our axis of symmetry is 1. We put that back into our parabola and we get a 4. So now we have our vertex. So now you've got enough information. You know that that y-intercept is 3. And when you use your axis of symmetry, you're going to mirror him. And you'll see that this is going to be your mirrored point. Now that we've got the information, we need to do a sketch of this. Now we're going to look at what it's going to look like on the coordinate plane. So now we're going to bring back in the inequalities here. First thing we need to remind ourselves is solid boundary line and dash boundary line. Same concept. If it's equal, it is solid. If there is no equal, it is dash. So in this case, we're going to use our solid because of the equal. Okay? And then we're going to talk about our shading. That has not changed either. This is a less than. So we're going to shade below because this is a less than or equals. If it happens to be above, then we shade above for greater than or equal. So let's see what it's going to look like. Alright, so here's my vertex at 1 and 4. So this is your axis of symmetry, right? So when you plotted your y-intercept, you went back into your axis of symmetry and went back out, right? And there's your, and if we bring this out, we find that the roots of our parabola are right here at 3 and negative 1. And so here's our graph. It is solid, remember? And we are shading below. So there's your parabola. Your y less than or equal to your negative x squared plus your 2x plus your 3. Again, it is opening down because it is a negative. All right, I can find it here. Here we go. It's a negative, so it's opening down. We are shading below because it was a less than, and we have a solid boundary line because of the equals. Again, you need to do a check, a really easy check here. In your you have a 0, 0 in your solution set. So let's check him out and see if we end up with a true inequality. So we're going to put that 0 in for all of our x's, and we're going to put the 0 in for our y. So now we have 0 less than or equal to negative 0 squared plus 2 times 0 plus 3. Well, we know these are completely out now, and all we have left over here is the 0, and all we have left over here is 3. So is 0 less than or equal to 3? It sure is. So you know that your graph is correct. Okay, I'm leaving you with two parabolas, two quadratic inequalities to graph, these two parabolas. I will attach this as a PDF to the post if you would like to print it. So you have your graph here and you have your information to fill in. Or you can just use some of your own graph paper. And you can do whatever you'd like. This will be due at the beginning of class. And remember, don't forget to fill out your WISC as well.